If we return to the Moon, is there a telescope on Earth today strong enough to watch astronauts walking around on the surface? No, I don't think any telescope could come close. For instance, Hubble has an angular resolution of about 1/10 of an arcsecond. It is approximately 384,000 kilometers from the Moon. 1/10 arcsecond is 1/36,000th of a degree, and a circle is 360 degrees. 1/10 arcsecond on a circle with radius 384,000 km is 2384000 pi 363,600,0.18617, so the resolution of Hubble would be 186 meters, much too large to make out a single human. To achieve the sub-1 m resolution needed to discern a person on the Moon, a telescope would need a resolution over 100 times better, which does not exist. I'm an astrophysicist, and I believe the answer is yes, maybe. First we need to calculate the angular size of a approximately 2-meter astronaut on the Moon. We can do this easily on Wolfram alpha. We find that the astronaut is about 1.04 milliarcseconds. As other users have pointed out, no single telescope is large enough to have this kind of angular resolution. Hubble is about a 100x too small. Typically, to resolve an object, you need the resolution to be at most half of the object's size. So you'd need a resolution of 0.5 milliarcseconds. But you don't need a telescope 100x bigger than Hubble to have 100x Hubble's resolution. An interferometer is an array of telescopes that have the light-gathering power of their total mirror areas, but the effective angular resolution is determined by their most separated elements. The most powerful optical interferometer in the world is the Chara array, located on Mount Wilson. It's a series of 6, 1-meter telescopes that are about 330 meters apart, at longest separation. This means it has the resolution of a 330-meter telescope. Chara has an angular resolution of 0.2 milliarcseconds, which should be plenty to detect our astronauts. Update: 7 hours later, someone asked a question that led me to think of an obvious concern. Will the astronaut be bright enough to be visible by a small telescope array like Chara? The Moon reflects approximately 12% of the light that hits it. Let's assume an astronaut is wearing a classic white spacesuit. That reflects approximately 80% of the light that hits it. Let's say then, that for equal angular sizes, astronauts are 6x brighter than the Moon's surface. The Moon has a surface brightness of approximately 4 mag/arcsecond 2. If an astronaut has an angular size of approximately 1 mas, then let's say they have a solid angle of approximately 1 mas 2. Then they are 6x 1 mas 2 1 arcsecond 2 6e-6 times fainter than a square arcsecond of the Moon. Which means their apparent magnitude is ~13 + 4 17. What sort of exposure time is needed to see a 17th mag object? Well, on the Kitt Peak National Observatory 0.9 m telescope, it looks like to get a signal-to-noise ratio of 10, we need an exposure time of 0.7 seconds. But Chara has 6 telescopes that are a bit bigger at 1.0 meters, so let's call this 0.7, 6, 1.0, 0.9, squared approximately 0.1 seconds. But I'm going to assume that optical interferometry is more lossy than a simple imager, like in the KPNO example. So let's just arbitrarily bump this up to 0.2 seconds. I'm not certain what sort of exposure time is necessary for a ground-based telescope like Chara to work well is. But their user's manual has an example where they use an exposure time of 8 ms. Now, is this fast exposure time needed in order to be smaller than the timescale of atmospheric variations? If so, then it's hopeless for our astronaut project. But, if it's instead the case that Chara had a rapid exposure time in this example because their target is very bright, then we may still be in business. Chara might be observing bright targets because they are big, because they are close, which is also why they are bright, rather than because they can only see bright things. In this case, Chara could afford to take slightly longer exposure times of approximately 0.2 seconds for our astronaut, even if that's a bit slower than the atmospheric coherence timescale, which is usually taken to be 0.01 to 0.1 seconds or so, depending on lots of stuff. So, because I don't know Chara's upper limit for exposure time, if there is one, I must offer an unsatisfying conclusion of maybe. Edit. Had the wrong link for Chara initially. Fixed now.